Hey guys, welcome back to my channel and this is Varun Tahin. So back in the earlier sessions, we have learned quite a few distribution functions and saw where all we can apply those. Now as we know that there are primarily two types of variable that are discrete and continuous variable. Specifically, if we talk about numeric variables, there can be various curves that can be drawn out of samples created from them. And thus today we are going to look into one of the most popular distribution curves known as normal distribution, aka bell curve, or also known as Gaussian curve. Now normal distribution is a type of continuous probability distribution for a real valued random variable. They are specifically important in statistics and are often used in natural and social sciences to represent real valued random variables whose distribution are not known. Therefore, physical quantities that are expected to be sum of many independent processes such as measurement errors often have distributions that are nearly normal. Their importance is partly due to central limit theorem. This theorem states that mean of any set of variates with any distribution having a finite mean and a variance tend to normal distribution as the sample increases. In simple words, it also means that the sampling distribution of mean becomes approximately normal regardless of the distribution of the original variable. So guys, whatever is the distribution earlier for a random variable, as the number of samples increases with a finite mean, the distribution becomes normal. So we will look into each of these terminologies in detail in this session. Now the curve we are looking at is the normal distribution curve, where y-axis represents the probability density and the x-axis represents the random variable, and mu represents the mean or average and sigma represents the standard deviation. So you can see here that in case of normal distribution, the mean, median and mode will be symmetrical at this point. That is, all of them will collide at the same line. So guys, mu or mean means average among the group of random variables. Then standard deviation is a quantity expressed by how much the members of a group differ from the mean value of the group. So we will look at this at the later stage, but for now you have to remember the rule, which is 1 to 3 rule, which is applicable with normal distribution, that says value lying between mu minus sigma and mu plus sigma is 68%. That means the 68% of the values or random variables are concentrated between mu minus sigma and mu plus sigma, which is this region. Then value lying between mu minus 2 sigma and mu plus 2 sigma is 95%, and value lying between mu minus 3 sigma and mu plus 3 sigma is 99.7%. So majority of the values lie in this region. Now some of the examples of normal distribution are heights of a group of adult men, IQ of group of men and women, and weights of Coca-Cola bottles. So you will observe, once you have a lot of sample data of this, and when you plot it on a graph with probability density on the y-axis, you will observe that you will get a curve similar like this, which is normally distributed, where mean, median and mode are symmetrical, and where 1 to 3 rule is applicable, as it is a normal distribution. And as you observe that these examples come from real life examples, it will be applicable for other real life examples too, where the population is huge. Now let's solve some examples using things we already know. So let's say that we have a normal distribution with a mean of 35 and a standard deviation of 5, and we have to calculate the probability of a variable taking a value between 25 and 45. Okay, so what we'll do is, using the 1 to 3 rule which we have seen earlier, we will calculate the various checkpoints, which is mu minus sigma, that is 35 minus 5, which is 30, then mu plus sigma, which is 35 plus 5, which is 40. So this falls under mu minus sigma and mu plus sigma, which is the probability of having x between 30 and 40, which we have seen earlier is 68%. But we now want to calculate the probability of a variable taking a value between this range. So when we calculate mu plus 2 sigma and mu minus 2 sigma, let's see what we get. So this is 35 minus 10, which is 25. This is 35 plus 10, which is 45. Okay, so exactly what we needed. This is between 25 and 45, which is, we have seen, 95% according to 1 to 3 rule. Now the first question was quite straightforward and we have got the answer from the 1 to 3 rule itself. Now what if we have asked to calculate the probability of a variable taking a value between 25 and 50? Now as we have seen that mu minus 2 sigma is coming up to 35 minus 10, which is 25. So the left hand is sufficed by this. But we have seen that mu plus 2 sigma is 35 plus 10, which is 45. So we have to extend this range because we are desiring 50. Let's calculate mu plus 3 sigma. So this will be 35 plus 3 into 5, which is 15. So this comes up to 50. So this is the right one which we are expecting. Now basically what we have to do, we have to calculate a region between mu minus 2 sigma and mu plus 3 sigma. Now again from the 1 to 3 rule, we can draw this easily. So this is mu minus 3 sigma, this is mu minus 2 sigma, mu plus 2 sigma and mu plus 3 sigma. Now we already know that this region is 95% and the whole region of mu minus 3 sigma and mu plus 3 sigma is 99.7%. But we have to calculate the probability for the region which is between these two. Now to do this, we will subtract 95% from 99.7%, which will be 4.7%. So guys, what we'll get if we subtract this region from this region, we'll get the region which is empty here, which will be equivalent. So we can say that 2a equals to 4.7 and a is equals to 2.35. So each of these regions are 2.35. Now as we are interested in this region, this is 95 plus 2.35, which is 97.35%, which will be our answer. Now let's look at one more example from 1 to 3 rule. So let's say that we want to find probability of x of having less than 40. In short, we have to find the probability of x falling in this region. Why this region? Because mu plus sigma, that is 35 plus 5 is equals to 40. So in short, whatever is smaller than mu plus sigma, we need to find the probability of occurrence of that. Now what we know beforehand is that x being between mu minus 3 sigma and mu plus 3 sigma is 99.7%, which is this total area. Now our strategy is to first divide this region, which will give us this region, and then divide 68%, which will give us additional region of these, and then we will add these two pointers. So as planned, we will take half of mu to mu minus 3 sigma, which will be 99.7 divided by 2, which is 49.85. Then we'll take the probability of mu minus sigma and mu plus sigma, which is again 68% as we have seen, and then take its half, which is 34%. So here A becomes 49.85 and B becomes 34%, and then what we'll do is to get this area, we will add both of these. So 49.85 plus 34 is 83.85, which is approximately 84%, or in probability terms 0.84, because this is out of 1. Now we will try and establish a real life analogy with the 1 to 3 rule. So this is actually like saying if you buy a loaf of bread every day and measure it, then mean weight will be 100 grams and standard deviation will be 1 gram for that loaf of bread. Now for 5 days every week, the weight of the loaf you bought that day will be within 99 grams, which is 100 minus 1, and 101 grams, that is 100 plus 1. Then for 20 days every 3 weeks, the weight of the loaf you bought that day will be within 98 grams, which is coming from 100 minus 2, and 102 grams by adding 2 to 100. Then for 364 days every year, the weight of the loaf you bought will be within 97 grams, that is 100 minus 3, and 103 grams, which is again coming from 100 plus 3. So here if you replace 100 by mean and the addition or subtraction to it as being the multiplication to 1 gram, it will be equivalent to 1 to 3 rule. Now this is all for today, guys. This was a shorter session to introduce you all with the normal distribution. In the upcoming session, we will see its variant, which is standard normal distribution, and also see how do we calculate z-score with and without using z-tables. We will also familiarize ourselves with central limit theorem, on which we already had a glance. Until next session, guys, please practice the concepts taught in this session, as these learnings will be carry forwarded in the next sessions as preliminary knowledge. Also, thank you guys for supporting my channel. Please do subscribe my channel if you have not done it already. I will be coming with more awesome content in the coming weeks. Until then, thanks, take care and happy learning.